Hello, I'm Hope Davis Wilson, and today I'll be speaking about kinematics and spatiotemporal gait characteristics during the 6-minute walk in participants with hip osteoarthritis. This work was supported by a VA Merit Award, and the views presented are mine and the co-authors. Previous studies have shown that individuals with hip osteoarthritis demonstrate smaller hip flexion and extension angles on the involved side. These previous studies have assessed gait biomechanics using motion capture analysis in a research laboratory. As shown on the right, using motion capture analysis, you typically evaluate gait over a few steps on a short walkway or perhaps on an instrumented treadmill. And as a result, you don't necessarily capture some of the variability that may be occurring during gait in clinical populations who have significant gait deviations. And it remains unknown if biomechanics change in individuals with hip osteoarthritis during prolonged walking, for example, during a 6-minute walk test. Inertial measurement unit wearable sensors make it possible to measure prolonged walking in a clinical population. Therefore, the purpose of the current study was to evaluate joint and segmental kinematics and spatiotemporal characteristics between limbs and between early and late time points of the 6-minute walk test in participants with end-stage hip osteoarthritis. I hypothesized that participants would demonstrate kinematic and spatiotemporal differences between limbs and between time points. As part of a larger clinical study, I enrolled 10 individuals with end-stage hip osteoarthritis. For the clinical trial, as part of the participants' baseline assessment, they performed a 6-minute walk test. And during that walk test, I recorded their gait biomechanics using an XSENS wearable sensor system. So prior to the start of the 6-minute walk, each participant was outfitted with the XSENS 8-sensor full-body IMU system. 2 sensors were placed on the middle bridge of each foot. 2 sensors were placed on the anterior surface of each tibia. 2 sensors were placed on the lateral side of each thigh. 1 sensor was placed on the sacrum, and 1 sensor was placed on the sternum. Prior to the start of the 6-minute walk test, participants performed a static and dynamic calibration to make sure that the sensor system had been calibrated correctly. And over here you can see the feedback that I was getting prior to data collection to make sure that the sensors were in their correct place. Now the 6-minute walk test is a cardiovascular fitness assessment designed for clinical populations. And it involves a 100-foot or 30-meter walkway, and participants walk as much distance as they can during the 6 minutes, going back and forth down this walkway. And XSENS were collected throughout the entirety of the trial. And during the trial, we were seeing our animated figure as well as a few variables being collected in real time to ensure high quality data collection and acquisition. Immediately following data collection, segment velocity, segment acceleration, and joint and segmental kinematics were calculated using MVN Analyze Animate software, which is XSENS proprietary software. One novel aspect of this study was our identification of stance phases throughout the 6-minute walk test. To evaluate and to identify each stance phase, over the first 50 seconds of each person's trial, identified local minimum knee flexion angle, identified by this red star, as well as local maximum hip flexion angle, identified by this blue star. At the location of the stars, I identified the antero-posterior foot velocity and took an average of that velocity for each of these local maximum and minima. And at the end, I found a foot velocity cutoff. So for example, for this participant's data on the right, the foot velocity cutoff was an absolute value of 1.3 meters per second. So anytime that absolute value dropped below 1.3 meters per second, I identified that as a person's heel strike. Anytime it went above 1.3 meters per second, that was identified as a toe off. And so that way I was able to identify the stance phase, each stance phase throughout the 6-minute walk test based on that cutoff. From there, outcome variables were calculated for each stance phase and averaged for the first minute as well as the final minute of the 6-minute walk test. For our statistical analyses, I performed separate paired t-tests. The independent variable was the first versus final minute of the 6-minute walk test, and dependent variables included peak hip flexion, peak hip extension, peak knee flexion, and peak trunk flexion angles, as well as gait speed, stride length, and step rate. For our results, we found no differences between our spatiotemporal characteristics of gait speed, stride length, and step rate. However, during the first and final minute, the involved limb demonstrated lesser hip flexion, lesser hip extension, lesser trunk flexion, and lesser knee flexion during the first and the final minute. So for the significance of our results, we found that asymmetrical movement compensations were present at the beginning and the end of the 6-minute walk test. They persisted and they were consistent, so we didn't see too many changes between that early and late time point. However, it's very cool that we were able to identify these asymmetries using commercially available wearable sensors, and we think that these wearable sensors can be used to identify movement asymmetries which associate with hip osteoarthritis progression within a clinical setting. Thank you, and I'll take questions at this time.